Back page. Last two examples. We're going to find the area of a triangular vegetable garden with sides of this. The first thing you should do is draw a triangle. It doesn't tell you it's a right triangle, so you should probably avoid making it look like a right triangle. I'm going to label the longest side length as 15, the shortest one as 7, and then the medium one as 12, and then try and figure it out from there. Or you could just label it all as ABC and then put it in as accordingly. And if it doesn't look right, that's fine. It doesn't matter. Okay, so AB is 15, and then AC is 7, so that means that this needs to be A, this needs to be B, and then this needs to be C, because then BC is 12. If that makes sense to you, awesome. If it doesn't, label your angles first and then label your side lengths. It doesn't matter if it looks correct. So we want to find the area. So first I'm going to write down area equals 1/2 AB sine of C. And I notice that I need an angle. I need an angle. So we've been given some information, but not all. So we have a few steps in order to get to what we need to do. So we need to find C or any of the angles. It doesn't matter. Try and think about which law would we use to solve for this angle. Hopefully you said law of cosines, because remember, if we use law of sines, it's a potential we could get multiple answers. It's also because we have all of the side lengths. So law of cosines is a good one to go to if you're trying to solve for the angle. So I'm going to solve for C. So first I need to solve for C, and then I can solve for the area. C I'll label as X. So I'll remember that with law of cosines, the side length that's opposite of whatever angle we're talking about is what goes on the outside. So 15 squared equals 7 squared plus 12 squared minus 2 times 7 times 12 times cosine of X. Cosine of X. Either use your numerical solve or use your PEMDAS operations. Subtract 7 squared, subtract 12 squared, then divide by all of this in the denominator, and tell me what you get for the angle. We should have gotten that the angle is 100.98 degrees about. So then we can use that information to solve for the area, because we solved for the first piece. Now we need to solve for the second piece. Area equals 1/2. And remember, it's the side length on either side of that angle. So we'll talk 7, 12, and then, oh, not cosine, sine of that 100.98. Go ahead and find out what the answer is. Your final answer should have been 41.2 meters squared. If you are consistently getting the wrong answers, I want you to double check the mode of your calculator. So up in the upper right hand, here on the TI Nspire will tell you whether you're in degree or radian. If it says rad, it is not rad, it's bad, so we need to go to degree. All right, last example. The floor of a gazebo has the shape of a regular octagon with side lengths 1.2 and is made of 8 congruent triangles. If we're ever told that we have a regular polygon, what it means to be a regular polygon is that all of the side lengths and all of the angles are equal. So a regular triangle would be an equilateral triangle. A regular quadrilateral, so a four-sided figure, a regular four-sided figure, is a square where all the side lengths are equal and all the angles are equal. So a regular octagon is an artistic interpretation of a regular octagon. So there's 8 sides, octa, and it's made up of 8 triangles that are congruent. So all 8 of these triangles are equal to each other. And that will always be true with a regular octagon or any regular polygon. You can always split a regular polygon into a number of triangles that are equal. So with a square, you could split the triangle or you could split the square into 4 triangles that are equal. So if we're trying to find the area of this guy, and our whole section is talking about the area of a triangle, we're probably going to find the area of the triangle and then multiply it by how many triangles are in this polygon. So I want to start thinking about, what is this situation broken down? Well, I'm going to take one of these triangles and blow them up and start thinking about it. It says that it has a side length of 1.2, which means that one side length is 1.2. It means that all of those side lengths are 1.2. So I know that the base of this triangle is a length of 1.2. I also know that all of these triangles are isosceles triangles. That length right there is equal to that length right there, which is equal to that length, equal to that length, equal to that length, and so on, right? Because it's a regular polygon. So I know that these side lengths are equal, which means I know it's an isosceles triangle. This is a puzzle. So if you're like, I would have never gotten that, that is okay. This is the first time you'll see it. It'll definitely pop up. It's a pretty popular IB question. So it's a puzzle, and try and think about it. You know you can bring out a triangle, and then what else can you figure out about the situation? Well, you can figure out that all of those side lengths are equal to each other, which means it makes for an isosceles triangle, not an equilateral triangle, so they're not 1.2, unfortunately. But we also then can find this angle right here, because I want you to notice that all of these angles come together in the center of the octagon to make a complete circle, which means that all of these angles add up to 360 degrees, that complete circle idea. So if there's 8 of these little angles all squished in there to the center, all 8 of those angles, which are all the same because all of those triangles are equal, all 8 of those angles will then add up to 360. If they're all the same, I can then take 360 and divide it by 8. This angle is 360 divided by 8 because 8 of these angles have been all squished into the center. And if you put angles side by side such that they make a circle, then that means that they all add up to 360. 360 divided by 8 is 45. No. Yes, 45. So that means that this angle is 45. Okay, we don't know enough yet about the triangle. We want to know what the area of the triangle is. So let's focus on that. We first said that the area of the octagon, I'll do 8 for octagon, is equal to 8 times the area of one of the triangles. So that's something that we talked about. Definitely something we can write down. We want to now find the area of that triangle. Okay, well, I could do 1/2 times base times height, but I don't really have enough information for that. I could also do 1/2 times AB sine of C. Okay, so I've got one angle and I've got one side length, but I'm definitely still missing a lot of information here. So what else do I know about isosceles triangles? I also know that their base angles are equal. Base angles are the angles that are formed from either of the equal side with the base, which is why they're called the base angles, because the base is what creates them. So those base angles are equal. So if both of these are equal, in order to solve for one of these angles, slash both of these angles, is you do 180 minus 45, which is equal to 135. You then divide it by 2, because both of these are equal, so if both of them will add up to complete to 180, you take out the 45, what's left is then split between those angles, so that's why you divide it by 2, which means that one of those angles, which means both of those angles, are 67.5 degrees. This is a long problem. You guys are doing great. So this is 67.5 degrees, which means that this is 67.5 degrees, which means now I have all of the angles, which is great. I just don't have enough side lengths in order to find the area of this triangle. So if I'm missing a side length, I need to figure out, how do I solve for a missing piece of a non-right triangle? Which law do you think we are going to use? Hopefully you said law of sines because we have a bunch of angles and we're just missing one side length. If I solve for that side length, then I can use that to solve for the area. So first, I'm going to solve for x, and then I'm going to solve for the area of the triangle, and then I'm going to solve for the area of the octagon. Here we go. So in order to solve for the x, I need to use law of sines. Sine of 45 over 1.2 equals sine of 67.5 over x. Go ahead and solve for x. You should get that x is equal to 1.57. We now use this information to solve for the area of the triangle. The area of the triangle is equal to 1/2 times 2 side lengths and the angle in between them. So you have all of the angles, and so now you just need to and all of the side lengths, because we know that this side length and this side length are equal. So you could use these two side lengths and use 67.5, or you could use these two side lengths and then use 45. You will get the same answer. I am going to use these two side lengths, and since they're equal, I'm just going to use 1.57 twice. So it's going to be 1/2 times 1.57 times 1.57 times the sine of the angle in between them, so sine of 45. What do you get? You get 0.87. It is weird. You should have done 3 sig figs, but this is the idea, is that you get 0.87, which is weird, but it's actually correct. So now, in order to find the area of the octagon, we take this and multiply by 8. So go ahead and tell me what the area of this octagon is. Multiplying it out, you should have gotten 6.95 meters squared. Whoa. It is really important to draw diagrams. It's really important to label your processes and your plan, right? So label out, okay, I need to find the area of the octagon, and I'm pretty sure it's made up of 8 congruent triangles. Okay, so I need to find the area of the triangle. And then start piecing together what can you figure out with the area of the triangle, knowing that it's an isosceles triangle and all of these pieces. So there's a lot of steps that go into it, but labeling out a to-do list is also a really good way for you to keep track. This was one thing that we did. We were coming from problems, last class, we were coming from problems where this is the only thing that we did. And now it's just one part of the thing that we did, right? We use this to then solve for the area, and then we use that to solve for the area of the octagon, right? There's so many steps. You cannot do this in your head. You cannot do this without properly keeping track of your work. You will lose track of what's going on. So please make sure that you're writing out all your work, drawing all of your diagrams, labeling out a to-do list, and it's going to help you stay on the right path. Great job.